Welcome back to school again with Professor Alex, and as I promised, we are going to dive into some division. Now, this is going to be a little bit more difficult than yesterday's multiplication, but it still should be a tad bit easy. But I'm going through the beginning process of each uh, formula that I give you, each concept that I show you, but I'm going from just your specific grade level to like sixth, seventh, and sometimes eighth grade levels because I want to get you guys prepared for what's about to happen next, but I also want to make sure that you understand fully what's going on right now, which is good because if you understand it in the fifth grade, third grade, fourth grade, then ideally you will only be doing review in the sixth and seventh grade because there's not very many concepts to introduce in the sixth and seventh grade that haven't already been introduced in the fourth and fifth grade unless you wasn't shown that in the fourth and fifth grade. So we're going to start doing some division. Now, you may see a division problem such as 9 divided by 3. Now, if you remember last class, I told you that it is not reversible to have 3 divided by 9. The same way 9 minus 3 is not reversible. It is not equal to 3 minus 9. You're not going to get the same answer. So when you're doing division, just like when you're doing subtraction, you want to pay attention to the direction that your numbers are. So we are doing 9 divided by 3. And with 9 divided by 3, you want to rewrite your problem. You always want to rewrite your problem. If you know the answer, you know the answer. But let's say you don't know the answer and you're going to rewrite your problem. You are going to write your 9, and then you're going to write this little funky thing on top of it. And then you're going to write the number you're dividing into 9 right here. Now, this is where knowing your multiplication is key. Factors kind of help, but knowing your multiplication is key. So factors of 9 are 1, 9, 3 times 3, right? These are the only multiples of equal 9. So when you're trying to figure out how to get to 9, 3 times 3 is going to be 9. But if you didn't know that, let's go off of if you didn't know that. We give you a number and you want to know how many times does this number go into this number. And when we do the 2, 3, and I'm probably going to stop at 4-digit numbers, you will understand that this actually matters. And you can use addition to get there, but I kind of want to start with this. 3 goes into 9 evenly. That is the key point. How many times does this number go into this number evenly? 3 goes into 9 3 times. You know this because 3 times 3 is 9. Now, once you do this part and get this number, your problem is going to be 9 minus 9. And when this number is subtracted by this number and it gets 0, that means your problem is done. If there was a remaining number here, then you got to keep going. Unless your teacher gives you significant figures. I'm going to go into significant figures in another chapter. But in this case, 3 times 3 is 9. Let me give you a little bit more of a complex problem. I'm going to do a 2-digit problem now with a single-digit divisor. So we're going to say 27 divided by 3. Okay, so same thing you would do, and when you're doing this on your paper, you don't want to put it way up at the top of the paper because your answer is going to go up here, and if you don't have room to write, it's going to be difficult for you to put your answer up there. You want to give yourself room to work, so you want to come some ways down the paper and then write your problem in here where you have room to write on top of the equation. You're going to put your 3 here. You're going to put your 27 here. Now 3 goes into 2 0 times because 3 is larger than 2. 0 times 3 is 0. 2 minus 0 is 2. And now, because there's extra, you're going to keep going. The next step is that you're going to take this 7, you're going to bring it down, and now how many times does 3 goes into 27? So how many times does 3 go into 27? You can do 3 times 10 to get 30, right? Which means 3 times 9 is equal to 30 minus 3, which is 27. This is why knowing your multiplication tables makes it easier for you to do division. So since you know that 3 goes into 27 9 times, you're going to put your 9 above the 7. 3 times 9 is 27. 27 minus 27 is 0. That means your problem is done. Now, I'm going to give you one that is a little bit more taxing on the brain, but I'm going to keep it a little bit simple for you so that you can kind of follow along. We're going to do an even number. We're going to do 3 divided into 26. See? So 26 divided by 3. Now, when you do this, I'm going to show you something that I didn't show you the last 3 times I did the problem, but it doesn't really matter that I didn't show it to you then, because you're going to kind of catch on as we work this problem out here. So 3 goes into 2 0 times. 0 times 3 is 3. You have 2. Now you're going to bring down your 6. 3 goes into 26 evenly. This is what's important. You don't go over. So 3 goes into 26 evenly. We're going to look at that. Eight times, because 3 times 9 is 27. Now you want to get as close to this number without going over. So 3 times 9 gives you 27, and 27 is higher than 26. So this number is wrong. 3 times 7 is 21. It is less than 26, but you can get 3 more in there to get 24. So 21 is wrong. So the closest to 26 that you can get is 24. 3 times 8. You only write your 8 here. 3 times 8 is 24. Now you're going to subtract 26 minus 24. It's going to give you 2. This is what I didn't show you the last couple of times that we did it. I explained to you that your answer is up here at the top. Now, in 3rd grade, 4th grade, probably even 5th grade, you're probably going to stop here. Your teacher's going to say, this is what's left over, because 3 cannot go into 2 evenly, which gives you a remainder of 2. This is your answer. In a class where the teacher is telling you that there's a remainder, that is your answer. But in 6th grade, 7th grade, we're going to see the same problem. 3 divided by 26. And you see how I keep drawing this way past the 26? You didn't notice that I didn't do 3, 26, and just do this. You notice how I'm always going all the way down a line? This is because subconsciously I know it's going to be more than that. There's going to be more to do than just that. And this is what we're going to do right here. In this scenario, I'm going to show you something that you're probably going to learn in the 6th or 7th grade, but you're going to love this now because it's going to help you with getting it done correctly. Decimal right here, decimal right here, 0.8. You always want to keep your decimals lined up. We're going to talk about decimals in a few chapters, but I want you to come to grasp this whole division chapter because you have 24, 2, you're going to put a 0 right here. You're going to bring that 0 down, and now you have 20. 3 goes into 20. The highest number closest to 20 is 18. To get 18, you need 6. 3 times 6 is 18. Now, this is going to be annoying for you because you're going to get another 2, which means you're going to put another 0, which means you're going to bring down another 0, which means you're going to do your 18. Now, we're going to do this for 2 significant figures because clearly this is going to repeat. So this is going to be 6, 6, 6, 6, 6, all the way into infinity. But in 6th and 7th grade, your teacher's usually going to ask you for significant figures. So even in this particular scenario, while 6 goes off into infinity, your answer is going to be then rounded by, depending on the significant figures. If you're going to do 2 significant figures, you're going to round this number either higher or lower, which will change this number to 0.8. Sorry. 6, 7, or if you're going to do 1 significant figure, it'll be 0.8.7. Now, I'm teaching you this because in science class, significant figures matter, whether it's 2 significant figures or 1 significant figure. Your answer is still going to be the same, but this answer is more precise than 8 remainder 2. So let me give you a 2-digit number divided into a 2-digit number. Now this is going to give you a little bit more of a complex feel, but if you've been following me along and you kind of understand what's going on here, then this is not going to be much more difficult than what we've already done. So I'm going to do a nice drastic number like 12. I'm going to do 12 specifically because if you've done your timetable chart, you should have your 12 timetables on here. So we're going to divide 12. Yeah, you thought that we're going to divide into 12. No, we're going to divide with 12. And we're going to do a number that 12 can divide into. We're going to do 60. Now, luckily for us, this is going to work itself out. But first things first, you want to see how many times this 12 goes into 6. 0 times, because 12 is larger than 6. So now you want to see how many times does 12 go into 60. Now, if you don't know your multiples of 12, you have 12, 24, 36, 48, 60, which is 5. And if you memorize your multiples, you can actually write it out just like that so that you can figure out what's going on. But because 12 times 5 is 60, your problem is done. So let's do 12 times 30. 12 goes into 3 0 times. 12 goes into 30. 24. Huh? Because it's 12, 24, 36. You don't want to go over 30. So that's 2. 2 times 12 is 24, which is going to leave you with a 6. In 4th, 5th grade, maybe 3rd grade, you're going to see remainder 6. And 2 remainder 6 will be your answer. But I'm going to go one step further. I'm going to give you 12 divided into 30. And you're going to put a decimal here, you're going to put a decimal here, you're going to add a 0, you're going to bring down a 0, put a 5 down. I'm sorry, put a 0 down. I'm skipping myself. 12 goes into 60 5 times. 5 times 12 is 60. Now your problem is done. Now, we're going to do a 3-digit number, a 2-digit number divided into a 3-digit number. And we're going to do something that's not on the multiplication table. 15. And we're going to divide that into 300. I'm going to say 300 because I know it's going to work evenly. 15 goes into 3 0 times. I'm going to bring down your 0. 15 goes into 30 2 times. But this is the key factor here. Even though you have 0 here, doesn't mean your problem is over, because still you have another number. So how many times does 15 go into 0? Because you still have to bring down this 0. 15 goes into 0 times. So 20 times 15 is 300. Which also means that 300 divided by 15 equals 20. So just because there's a 0 here doesn't mean that your problem is done. If there's a 0 here and there's nothing else here, then your problem is over. But because there was another digit here, because this could have been a 6, and you would have to work the problem out. And in fact, that's exactly what we're going to do. We are going to divide 15 into 306. $15 goes into 306. Now you know 30 minus 30 is 0, right? Next thing you're going to do is bring down your 6, but you're bringing your 6 all the way down here. So you have a 6. So 15 goes into 6 0 times, because 15 is larger than 6. So now you have 6, which could be remainder 6 in a class that has remainders. But if the teacher asked you for an exact answer for this particular problem, the next thing you would do is put a decimal here, put a decimal here, add a 0, bring down the 0, and then you would have 60, where 5 goes into 60. Or sorry. Yes. 15, not 5. 15 goes into 60 4 times, because 15 times 4 equals 60. And because 60 minus 60 is 0, your problem is done. And the reason why your problem is done is because there's nothing here and there's nothing here. That's why your problem is done. So your exact answer is 20.4. So let me write your answers for you in this particular equation. And then later on in higher grades, if you keep following me, I'm going to show you some more complex division. But I'm just going to write this down for you. 306 divided by 15 is 20 remainder 6 in a problem with remainders, or 306 divided by 15 is exactly 20.4. That is all I'm going to give you for today because I want you guys to decompress. Next time we're going to do a review. We're going to go over multiplication, division, adding, subtraction, and a few factors. And we're going to compile those into complex equations where we're adding, subtracting, multiplying, dividing. And this is where we're going to be really working on our orders of operation. This way you will get better familiarized with when to put your parentheses, exponents, adding and subtraction in there. I'm probably not going to give you many exponents until the very next chapter, but we're actually going to at least touch on it tomorrow, and we should be able to work through all of these problems. So what I want you to do is I want you to remember to like and share and also comment. If you have any questions on any problems that I worked on today, if you have any problems you want me to work on, please feel free to comment on those problems. Definitely share and follow if you've got any questions, so that when I provide you with the answers in the next class, that you're able to follow along. And also, I want you to, if you'd like to use me as a tutor, the information down below is going to be in the description, a link that'll take you to where you can sign me up as a tutor, where I can show you how to work these problems out and work with you, because one of the things I like is repetition. Everybody makes mistakes, as you can see, but what I like to do is I like to be able to practice with my students, give them the time to understand the problems and equations, and then help them build the confidence in knowing what they need to know. So with that being said, I really appreciate your time and enjoy your recess.